So document number one, if you have your PDF, please open that. Document number two, if you have your R, please open your R. Next, if you have your Excel, which is an empty cast, all of these I've opened them. Please open the empty cast. If you are ready, type R or yes. If you are ready, type R or yes. Fantastic. I guess some people that are ready. So I want us to quickly load the data, and to load the data, copy, do Control A to highlight the entire data, and do Control C to copy the data. Then go into your R Studio. The command that we typed the last time, we call this data. Okay, and so this command, which I have highlighted, just highlight it or just click anywhere on the command and click run. Or do Control Enter. It will run the data. To be sure that the data is loaded, look at the bottom of the console. You will see the same command in blue. You will see the same command in blue, which will indicate that your data has loaded. Now that your data has loaded, we can do a couple of things. Last time we looked at the top 7 of the data set. We looked at the head, and we indicated that if you want a particular number, you can indicate that to get the data. So if you type head into bracket data, comma, 7, it will show you the top 7 of the data. If you want the last 4 of the data, you can type till data, comma, and then type 4. And that will, when you run that, that will give you the last 4. As you can see at the bottom, you see that I have the last 4, which is 29. I have the last 4, which is 30, then 31, then 32. Okay. So these are the last 4 of the rows or casts that are in this data set. We're able to look at all of this. And then we are ready now. I indicated that you should load all the packages. So the package we used was the library car. And I want to believe that you've loaded that package. If you install the package, to load it, you click on it and run it. So now let's look at some few things we want to do with this data set. Okay. One of the very first things when you have a data set, and you see, I'll give you a data set and I'll tell you to do a lot of the things I'm doing. One of the things that we'll do first with the data set is to have a summary of the data. To do that, you type summary. If you have an internet, the moment you start typing, it will pop. So you type summary into brackets, just double click on the name, and then type the name of the data. We call it data. That means that I am typing, I'm looking for the name of this data. And the name of this data, currently the data is in the global environment. So you type that and you click run. And when you come down, you will see the result of each variable, a summary of the result. Now, for many journal articles or theses that you write, you will notice that for quantitative work, even for categorical, like nominal or ordinal, you will sometimes have to generate a descriptive statistics of the data. Now, this very one that you see here You have a descriptive statistics of the data. And basically, you get to the mean. Taking the MPG as an example, that's a miles per gallon. You have the mean, which is 10.40. You have the first quartile. The first quartile refers to the 25th percentile of the data. The second quartile is also called the median. The median. And then you can also see that the summary will give you the mean. And then it will give you the third quartile, which is the 75th percentile of the data. That is only 5% of the data. And then you have the maximum value. So you have the minimum value, the maximum value. Now, this summary statistics of the data is not too good, because when you look at journal papers, they will also give you the standard deviation. And even more than that, ketosis, variance, range, interquartile range, skewness, and several other things. So this is a quick way to have a feel of your data. But we need another package to get a real feel of the data. And that another command, that command is known as describe gen. But before you do that describe, you do describe data. But before you do that, you got to ensure that you have a certain package loaded. The name of the package you got to load is called library psych. Library psych. So let's type library psych. Now, last time I told you to load the data before coming. Library psych. So the command, the package itself is called psych. Okay. Now, in order to be sure that the data is there, go to the packages section. The packages section. And then when you scroll down to P, you will see psych, PS. And this psych is here. To look, so it's a procedures for psychological, psychometric, and personality research. I have installed it. So once I run this command library, this command from the library, or this package from the library, it will load the psych package right now for me. So run that. Okay. And now let's describe. After you've done that, you can now describe the data set better by using the describe and then type in the data. This is going to give you a bigger summary statistics of the data. And guys, understand the summary statistics of each data. I'm going to give you pointers. And I want to take note of these pointers. So let's run that and see the summary statistics. So this is a beautiful summary statistics of the data. You can see it at the bottom, right here. Let me go up. So you can see. Now, before I talk about this, let's talk about the one before this, the summary. You can see that the summary, for some of the data, it did not give you the minimum and the maximum and the descriptives. For example, for cylinder, it did not give you. It only mentioned that it gave you the length of cylinder, the class for cylinder, which is a character, the mode for cylinder, which is, and all of these things that it gave you are because cylinder is a categorical variable. Take note. So all the categorical variables are sensible enough not to give you their summary statistics. So what does this mean? Let's say you are talking about sex, male or female. And then you tell that I want to know the maximum value for male and the minimum value for female. Now that is crazy because this is a categorical variable. This is a categorical variable. You have 0 or 1, 0 or 1, 0 or 1 for female and male, for female and male. And so to tell me that I want to know the maximum value for sex, or I want to know the minimum value for say it doesn't make sense, and I recognize it that it doesn't make sense, and that is why it gives you this. Another one is, the others that you can see right there. But the describe package even goes further to tell you something. The describe package will give you the numerical values, but in order to tell you to be careful about how you understand this, it gives you a star on each of these, each of these categorical dummies. So for cylinder, I gave you the value, but I gave you a star. For automatic and manual, cars, it gave you a star. You can see clearly that the maximum value of that is, what is that? The maximum value is 1. The minimum value is 0 because this is a dummy. This is a dummy. It won't make any sense to even talk about the mean, And then the gearbox and the carburetor, all of them, they were starred. So when you have those stars, it should give you a signal. Yes, Joseph.
No, good afternoon.
Yeah.
Please describe. It's telling me error in describe data.
Okay, did you install the package and you can see site on the right like I'm showing you?
Yes, please.
And it's site text. It's site checked.
It's not checked.
It should be checked because it means that you have not run it. So check it first before you go to run the describe.
All right. No, please, that's coming. Thank
It's
you.
working now, right?
Yes, please.
Good.
Thank
so
you.
anytime you have a package, that is why instead of checking, I wrote the name of the package. As you can see, I wrote the library site and then ran it. So that's another way you can deal with it.
Thank you.
Guys, work this along with me because you will notice that you'll be given an individual assignment and it's loaded for you to be doing it. And each has about 40 questions alongside. It's very important that you know what we are doing. Okay. Next. Next thing we are going to do is, so we have the description of the data set. So let's take one of them. Let's take MPG. MPG is the miles per gallon. So based on this, what is the mean of MPG? What is the mean of the miles per gallon? You can tell us.
20.7.
Good. What does that mean? What does the mean? What does that
The mean is the average.
But don't define mean for me. What does that mean? What is the meaning of the mean here for this? Kingsley.
So, Doc, the mean here means that on average, the cars used in this data set travels by 20.09.
20.09 what?
Miles.
Well, you can't say miles per gallon. Eh?
Sorry.
You can't say miles per gallon. Yeah. So what it means is that if you close your eyes and you pick a typical car runs an average of 20.09 miles per gallon. Okay. Now, some will be more than that, some will be less than that, but a typical car has this. Now, there is also the median that you can find. If you can see, the median here is short of the mean. The median is 1920 or 19.2 miles per gallon. What is the advantage of the median over the mean? Guys, These questions, you get them somewhere, and it's important you are writing them and writing the answers as well. What is the advantage that the median has over the mean, and an advantage the mean has over the median? So don't just calculate, make sense of the calculation. Anybody? Yes, Desmond.
Yeah, okay.
Mm-hmm.
Can we say that the median is not actually affected by extreme outliers?
Mm-hmm. That is correct. That is true. So guys, he says that the median is not influenced by outliers. What do we mean by that? This is what we mean. If I have the ages of some people, and these are the ages 4, 8, and 90. And then you have the ages of another group of people in a house, which is 10, 11, and 14. When you calculate, take a calculator. Those of you who quickly have a calculator, take a calculator. And when you find the mean of what you have here, you will notice that the mean for each one, the first one will be 4 plus 8 plus 90. Then you divide by 3. That's 34. 34. That's the mean for the first group. What about the second group? Someone should tell us quickly.
The mean for the second group would be 11.6, so 12.
So when you have 11.6, on the basis of this, you would say that the first group, on average, they are older than the second group, isn't it? That's what you say.
Right.
Yes.
On average, a typical person, you will close your eyes, is older in the first group than in the second group. Now, the second group of people there will laugh at you. Because you can see some 2 small boys in there. But that's a typical person. But when you now take the median requires you arrange in alphabetical order. And then you pick the middle guys. So when you arrange in alphabetical order and you pick the middle guy, the first group, the median is what?
It
The
should be
second,
8.
8.
and the second group is 11.
11.
Yeah.
So on the basis of this, you will say that which group is having the older group? Which group is the older group?
The second group.
Instead of the first. By the way, the word average is for both the mean, the median, and the mode. Take note. Average is for all of them. Just that we've been talking a lot about a mean, so it makes it look like the mean is the only average. It's not the only average. Median is also average. Mode is also average. So by using the median here, you are avoiding that outlier 90-year-old man who has inflated the ages of the first group. Therefore, using the median prevents you or allows you to handle outliers or extreme. An outlier is an abnormal observation. It's not part of the normal ones. I think you all get it. Now, having said that doesn't mean that you got to always use the median. So when is the mean advantageous to use? You can tell us. When is the mean advantageous to use? I'm a very pragmatic person. I'll ask you these deep things of your normal work. Suppose you've calculated both and I tell you which one should we use. And sometimes I'll tell you to compare the mean of some. In fact, in one of the assignment I will give you, there are about 6 different groups, and each group has got like 3 to 10 groups. The mean has an advantage over the median. One, if the data is normally distributed, the mean is very advantageous. You see, the median is advantageous only if the data is not normally distributed. Like in this case, it's skewed toward that older 90-year-old person. So if the data is normally distributed, and we will learn how to test for normality. So once you detect that the data is normal, mean is sensible to use than the median. And the mean is an approximation of the unknown distribution of the data. So you got to learn some of these things. Another thing you will notice is the standard deviation. In this example, the standard deviation for miles per gallon, I'm using miles per gallon for a reason. The standard deviation for miles per gallon is 6.03. This example shows that the standard deviation is lesser than the mean. So the standard deviation is 6.03. The mean is 20. The mean for miles per gallon is 20.09. You can see that the mean is bigger than the standard deviation. What does that mean? What does that mean when the mean is bigger than the standard deviation? Think about that. What does that mean? Now, what this means is that majority of the data points are, oh, Nana Buama.
No, so I was going to say, I mean, if the standard deviation is lower than the mean, it means the degree of dispersion from the mean is lower. So the data point is not widely distributed
The
around the
data
mean.
point is what?
It's not widely distributed around the mean. The degree of dispersion is lower than the.
Good. When you say it's not widely distributed around the mean, what do you mean?
So the deviation.
Don't use mathematical language. Imagine you're speaking to a 7-year-old child.
Yeah, so maybe the difference from the mean is
The
not
difference
too
of
wide.
what from the mean?
The difference of the distributions.
You're confusing that 7-year-old boy. Einstein said that if you cannot explain to a 7-year-old child, you don't even understand yourself.
Yeah, I guess I don't understand.
You have the idea, though. See, you are using a mathematical or statistical language to explain the thing, and that is normally what people wrongly do. So when people don't understand something, what they do is that they try as much as possible to lambast you by raising your mental gymnastics to the highest apogeic level. And it makes it look like these people are smart when they are Confucianists. We'll try.
Prof.
Paul Besson.
Yes,
How
please.
may I help you?
I want to say that if the standard deviation is lower than the mean, it suggests that the data is clustered around the mean.
Why are you all using this cluster around the mean? Cluster around. I get it. And now you've confused that guy. What is cluster?
Okay, it's surrounding. I mean, a lot are found closer to the mean. A lot of the data.
See, now
is
you are
found.
using a simpler word, closer.
Yes, please.
Closer. But even better is what? Yes, this one.
Yeah, I think he has used a lesser word. So I was trying to say that it only means that the observations are not too far away from the mean.
Good, but let's make it even better. It means that you are all using the mean. The observations are not too far away from each other. Let's make it like that. It means that the observations are closer to each other. They are closer to each other because the mean was obtained by coagulating or by combining or by bringing everything together. So for each one and each one and each one, the observations are nearer to each other, nearer to each other. That is why when you measure the total asset of a company or multiple companies, and you realize that, and you see some of these things in your analysis, you realize that the mean is lower than the standard deviation, or the standard deviation is bigger than the mean. What would that mean for total assets? Let's say total assets of banks, of all the banks, and then you realize that the standard deviation is bigger than the mean. What is the implication of that? Remember, total assets here is a measure of size of the company. What's the implication of that? I'm showing you how to do analytics, data analytics in your work. Yeah, so what I mean. Kingsley, are you the one about to talk or what?
Doc,
Yes, Naya.
yeah, so please, it will mean that the observations are very far
No, I was
apart.
very specific with what observations I was talking about. So be specific.
Yeah.
Please come again.
I didn't say observation. I was very specific with what kind of observations I was dealing with.
Okay, the total assets of the banks
Mhm.
are far apart from each other.
Yeah, what does that mean?
So that makes the standard deviation higher than the mean.
Yeah, so what does that mean? My question is, what does that mean then? See, now you're picking the values and thinking in practical terms. Instead of picking the values and just saying that, this time you got to think and connect it in practical terms. What does that mean? Samuel.
And
Yeah, so Doc, it means there are some companies that have greater assets and there are some companies that have lesser assets or whose assets are far lower than what the average is.
Good. So it means that when you look at the industry of these banks, when you look at the industry, they are bigger banks because I told you that size is total asset is a measure of size. So it means that some of these companies are big and others are small. In fact, some are very big and some are very small. One last one. When the standard deviation is 0, what does that mean? If you have been following the discussion so far, you should be able to raise your hand and tell me what it means. When the standard deviation is 0, what is the implication of that? Samson.
Thank you. So from the discussion so far, when the standard deviation is 0, it signifies that all of the data points are equal.
That's it. It means that they are all perfectly the same. It means that if you have 20 in one of the data, it's the same 20 across every observation. Guys, please think and note some of these deep things down. So sometimes people will calculate these things and they don't even know what they mean. Okay? Calculating these things and not knowing what it means is worse than calculating. Yes, Kingsley.
Yes, Doc. So
talking about the standard deviation being bigger or lower than the mean, are we looking at magnitude or just the fact that it's bigger than it or lower than it?
What do you mean by are we looking at magnitude or just that bigger?
So, for example, here we are seeing the mean being 20.09 and standard deviation is 6.03. So, will the interpretation be same if standard deviation were to be 19.99?
$19.99. It's still
Yes,
lower.
which is still lower than the 20.09.
Yeah, it's still lower. If it is lower, it's lower. Even if it's the same.
All right.
Yeah. Yeah. You see, the key point is that the degree indicates how much, if that's what you're looking at. It's a matter of degree. It's not of a kind. It's not of a kind. It's a matter of degree. But you know that if it is bigger than, if the standard deviation is going to be bigger, it means that if it is bigger, you would have actually concluded that some are very big, some are very small. But now you couldn't conclude anymore that some are very big or some are very small because they are very close. So let's say they are the same. Okay.
Yeah.
If they are the same, you wouldn't have concluded the way you would have concluded if it was very low.
Yeah.
Yeah. You wouldn't have. Okay. But you know that anything below means that they are getting closer to each other.
Mhm.
Anything zero means that they are perfectly equal to each other. And anything higher means that they are far away from each other. You can only conclude that. You can't talk about much of a degree unless you have other ones to compare.
Okay. Right.
Okay. Take note that the standard deviation, another thing you can use to detect whether or not there is a situation of death. Of course, I'm not going to talk about each one of these statistics. You got to learn each one of them. For example, people confuse skewness with ketosis, okay, which is not really the same. One is looking at the thickness, whilst one is looking at the flatness, okay, or how it flattens, whilst one is looking at how it peaks. Or better still, one is looking at how the entire distribution is to one side from the center, whereas one is looking at the peakness going up or down of the other. The ketosis looks at the peakness, while the skewness looks at the left and right. So one is looking at left and right from the mean. One is looking at top and down at the mean. Learn these things. Learn these things. So that you can, and also when you learn the range, also learn the interquartile range. Because the range is the highest minus the lowest. So if you look at the highest value here, it is 33.9. You look at the minimum value, is 10.4. The range is the difference between the two. And so with that range, you can now find the interquartile range. But you can't find the interquartile range unless you know the first quarter and then the third quarter. Because it is the interquartile range is actually the third quartile minus the first quartile. Learn this. This third quartile is also the 75th percentile. This first quartile is a 25th percentile. Learn what that means. It's very important. It's very important. Sometimes you need that. And there's one that is not here, but you can later learn about it. It's known as a coefficient of variation. Okay. The coefficient of variation. Yes, somewhere. Normality. Yeah,
What are yes, please. What are acceptable ranges for the skewness?
Sorry, you sound very far away.
acceptable ranges for skewness and ketosis.
What are the ranges? Well, the best way you can answer that is not even for me to give you the range, it's for you to read about them. Because if you have read about them, to be honest with you, you would have known what the ranges are.
It's 3.
Learn them, because we have a lot of the ketosis. We have the platicketic, we have the calicetic, we have the ellipticetic. You have to know what each one of them need before you even know the ranges of them. Those that are deep, because even the mean and the standard deviation, I'm giving you a bit of deep things around them, not the normal one people tell you. But I want you to go and read even deeper ones at your level. I want you to do that. So don't just write the descriptive statistics. And I've seen papers do that. Don't just write the descriptive that talk, English. Prove that you understand. There are some of them you don't need certain descriptive statistics. For example, in the financial market, there's some kind of descriptive statistics you need more than the others. You need a coefficient of variation. You need a lot about the skewness and the ketosis. You need about the standard deviation. You need the mean. But there are some, especially ordinal and rank data, you need more about the mean, the trend mean, and all of those things. Learn about that. Learn about it. Okay. So that is the first thing you got to always know about your data. It's known as descriptive analytics. In the area of artificial intelligence and business analytics, you got to know this thing. It's necessary. It's necessary. Okay. There's something else you can also do. And this is sometimes something that a lot of people don't normally remember to do. You can find out about groups of some of the results. Okay. You can find out about groups. For example, you might want to find out about what is the mean of, for example, when you look at the data, we have cylinders. When you check cylinders very carefully, okay, you look at cylinders very carefully, we have 8-cylinder cars, 6-cylinder cars, and other cylinder cars. You can even do what is known as contingency table. Okay? Let me see if I can show you a bit about contingency table. Because it's very, very important to learn about this contingency table. Okay. I want to just show you something here. Where is mine? Okay. I can't find. Okay. So I'm going to put something here and create a quick contingency table for you. Okay. I've not attached the data. Okay. But I want to, if you want to attach the data, you attach it like this. So I don't want to attach the data. So you just use the data. Yeah. I want to create a quick contingency table. You create contingency table, and this is one of my questions, so you should know. You create a contingency table for categorical variables. Okay. So we look at the variable. Which ones are categorical? Cylinder is a categorical. So I can create a contingency table and make one of them to be cylinders. Don't worry, once you generate it, you should be doing it as I do. Another categorical variable we have is automatic and manual, okay, which is AM. In fact, let me even use gearbox because that one has got many categories. Gearbox. And then you also have carburetor. So I've used 3 categories. Okay? And for each one, I'm picking it from the data set. So I'm going to create a contingency table on this, my data called data. Let's run that, and you see some beautiful contingency table created here. Okay, so this is the contingency table that has been created here. To appreciate this, let me just go up. Oh, it's quite a lot than I even thought. Oh, it's quite a lot. Okay, so let me just limit it because otherwise, let me just limit it. Otherwise, you're not going to see a lot. So let me change the carburetor. Because carburetor is quite a lot. Let me change it to AM as to whether the car is automatic or manual. Let me run that. Good. So that one looks better. So let me scroll up so that you guys can get. So look at this contingency table above. And look at it here below. The table says that I want to know among the cars, among the cars, among the automatic cars, look at it, and then also among the manual cars. Among the automatic cars, we have cylinder type and then gearbox type. The cylinder type are 8, 4, and 6. These are 3 different types of cylinders. And then the gearbox, you have gear 3, gear 4, gear 5. So I can ask you, or you should know something like, how many of the automatic cars have gear 3? Who can tell me? How many of the automatic cars have gear 3? You can raise your hand and tell me. How many of the automatic cars have gear 3? Naya?
No, please, 12.
No? Desmond?
15.
Did you say 1.5 or 1.6?
1.5, please.
Correct. It's 15, guys. And this is why. Because so you got to come to gear 3 here and count all those that have gear 3. That is it in that column. Not only this, okay, not only the 12, but the 12, the 1 and 2. These are the cars that have, gear 3 and they are in the automatic world. Now, among these cars, how many of the manual cars have 4 cylinders? How many of the manual cars have 4 cylinders? Samuel. Emmanuel, sorry.
Doctor, 8.
It's 8. And that is 2 here plus 6 there. But if I were to ask you...
But Doc, I have a question for you, sir.
Go ahead.
Yeah, we just generated the continuity table. Then there was a metric that was generated. How can we use that the items on the row, i.e. on the top 5, 4, and the 3 stand for gearbox?
Because you would have already seen this in the data set. Okay. You would have already seen. That is why I showed you the data set before. So when you go to the data set, and then you say, show me the tail of the data. So when you go to the tail of the data, you see here, that is carburetor. Carburetors are 4, 6, 8. You can see them here.
Okay. No, I'm okay. Because I was wondering how I can infer from such a table what stands for a GR and what stands for the other. Now I'm okay. Thank you very much.
All right. So, guys, you should know how to generate a contingency table to have a feel of your data. And you can do multiple. If you add a third one, sometimes some of them, the more you add, it will be very confusing. But if you want to do a lot of, analysis, suppose I were to add the one I removed, which was a carburetor. Okay. Now you will have quite a complex. This one here, I'm telling you, I'm sure it's going to be complex. Okay. Let me just delete this and then show you. Okay. So here, you see, it's so long, complex from all the way from here. You have to know types of each one in what, types of each one in what. But the key point is that 2 of them, 3 of them might give you a sense of the nature of your work that you're doing. Now, our data is quite small, and so you can look through a few things. But remember that when your data is large, contingency table is very good. It can help you to do a lot of things. Learn how to do that. Okay. All of these are just having a feel of your data, just having a feel of your data. Now, you can also have something like this. Okay, let me just delete this and try to have that. You can also tell, and I'm going to show you something here. It's nice to bring the name of the data in front of this, and then you can now run it. I want to run this and show you, then you can copy it. So please copy this, aggregate empty cars by list data is already in your notes actually. Data $cylinder, and then the function that I'm looking for is the mean. And then you have not available being true. So here's the thing. Sometimes you might want to have just you want to group the thing according to, you want to find the descriptive statistics according to groups. Okay, according to groups. And so the kind of group, so let's say that in this very example, you have group 1, which is 8-cylinder cars. Okay. And all the 8-cylinder cars, you just want to know their miles per gallon. Or all the 4-cylinder cars, you want to know their miles per gallon. So you want to check whether there's a connection between an 8-cylinder car and its MPG and a 6-cylinder car and its MPG. You're going to check that. I see a hand up, and that is Samuel.
Sorry, Doc. Doc, so please, with the thing, what you've typed out, I see we have empty cars in there. But our data is data, not empty cars. So are we supposed to maintain the empty cars?
Good. Please, you can just even use data because we change this thing and call it data. It will be the same thing. Okay, so it's the same thing here. It's better even like this because the data that we use, that's a good question. The data that we use, we actually incorporated categorical names and not numbers. The empty cars actually use numbers and not categorical names. So it's good to use the word data so that anything that is of category, it will not give you a number. And like you can see there, the automatic is a categorical variable, so there's no number. Gearbox is a categorical variable, so there's no number. It says NA. And then carburetor is a categorical variable, so there's no number. Car type is also categorical, so there's no number. So you want the R to give you the MPG. So from this, you can detect that all the 4-cylinder cars, they have a higher miles per gallon, the highest, followed by the 6-cylinder cars. They have 19.74, the next higher miles per gallon. And then the 8-cylinder cars, their miles per gallon is 15. They have the lowest. So you are able to get some descriptive statistics according to groups. According to groups. If you don't want cylinders and you want to even check between automatic and manual, just come here and change this thing to AM for the automatic and manual. And just run it to give you the aggregate. Okay. I don't know why sometimes they give you a couple of warnings, but the results still come. So you can see that there's now a data between automatic and then manual. And just looking at this, you can see that between automatic and manual, you can conclude that which of them have got a higher MPG. You can see that manual has a higher MPG, that is a miles per gallon, than automatic cars. Okay. So just using this aggregate feature, you are able to, look at the statistics according to the groups. So it's like, I want to know how many males have a height. I want to know the height of all the males. And I want to know the height of all the females. I want to check whether the males are taller than the female. Okay. And later on, we'll learn about statistical analysis, whether they are taller significantly than the female. This is a quick feel of how the males are taller than the females or not by looking at the numbers. Okay, and the next thing later we'll do next time will be whether that is significant or that is not significant. You are filling your data. You are filling your data. So that is one thing you got to note. So first, you remember how to generate the descriptive statistics. Second, remember how to generate the descriptive statistics according to groups. So this very one that I'm showing you is called, and by the way, you should bring the hash symbol and write your instruction. It's like note. So you can write an instruction after the hash symbol and say that gives descriptive stats according to group called automatic and manual. Okay. So you just give an instruction to guide you so that next time when you see the command, if you're a beginner, some of these commands you don't know. But as you go further, the moment you see it, it helps you to know that, okay, this is what this is about. This is what this is about. How do you know what this is about? It's your constant using it to get to know what it is about. All right. Now, so know how to generate descriptive statistics and not just generating, but interpreting them. Know how to generate descriptive statistics according to any group. Know how to generate contingency table and how you can, explain the contingency table. I wrote a paper in 2017 in energy economics. And in that paper, there was a lot of course, it was a very highly demand mathematical paper, but very applied. It was applied to all the oil companies in the world. And we used a contingency table. Do I even have it here? We use a contingency table to explain, I think I have that paper because I gave it to somebody today, and explained how the contingency table, guys, please, do you see the paper here?
Yes, Doc.
Yes, Doc, we see it.
So this paper.
Yes, Doc.
Oh, and I told you that I want to write some great papers with most of you. So those of you who have contacted me, keep contacting me so that we start. So this paper that I wrote was in energy economics, as you can see. And when you go down here, I used a contingency table. I created a contingency table. Oh, I didn't bring it. Oh, yeah. The paper told me that I have done too many things, so I should remove that part. Yeah, it's not here, but it's in the original. Okay, but I didn't bring the table, but I brought the statistical differences on the table. So the table had oil firms according to ownership. That is whether the oil firm is local or international. Okay, whether it is local or international. Then I also did it whether it is multinational, local, multinational, international, international, local, international, multinational. Okay, I did that. Okay. I didn't show the table here, but I brought the statistics here because it was taking space. So what's my point? My point I'm saying is that When you have an understanding of some of these, you can generate some incredible works. You can show some incredible things. I think a bit of that is here. No. Yes, but anyway, these are the groupings that I did. Okay. But this was a different thing, but I did something related to the descriptive statistics. All of these things will do. Let me just move on. So, ladies and gentlemen, that is the first part. 3 things we've looked at. The next thing that you want to know is to check whether the variable is normally distributed. Take note. I'm going to take only MPG to check. How do you know whether a variable is normal? You know when a variable is normally distributed if the p-value is big. Normally, this is rather the opposite. The data is normal when the p-value is big. When I say big, I mean the p-value is bigger than 5%. By the way, what is a p-value? The p-value, now remember, whenever you are testing something, okay, what I just said is a test, whether the data is normal. So I can check whether displacement is normal. I can check whether MPG is normally distributed. I can check whether, any of the variables, where are they? Okay, let's look at some of the variables. What are some of the variables? Anytime I want to know some of the variables, I have to come back. I have to come back and look at the head and the tail of the data. Okay, good. So let's say I want to check whether Q-sec is normal. The weight of the car, whether it's normally the drag, the horsepower, the displacement, the MPG. I want to check whether they are normally distributed. Now watch it. I'm focusing on the numerical variable. Write it down. You only check whether the numerical variables are normally distributed. You don't check whether categorical variables are normally distributed. Of course, they are not going to be normally distributed. They're categorical. Yeah, categorical. But numerical variables, you want to check whether they are normal or they are not normally distributed. And so to do that, you do the analysis and compare 2 things, the p-value and the alpha. Alpha is always given. There are only 3 alphas generally in the world, or 4. 1%, 5%, 10%. The alpha is the expected error. So anytime you are doing some analysis, you're expected to make some errors. You understand? The error you are expected to make. The error you are expected to make. This error is known as the alpha. It's also called the level of significance. Alpha, the level of significance. You are allowed to make that error. So if the softwares automatically choose 5%, that's the default. The 5% is the default alpha. You are expected to make that error. Okay. Now, what do you think the p-value will be? If the alpha is the expected error, the allowable error, what do you think the p-value will be? What kind of error would that be? If you're an accounting student, you should get to the clue. If alpha is an error you're expected to, yeah, Kingsley.
The actual error.
The actual error. You see, you didn't know, he knows. So you should write it down. You shouldn't write it down. That's how you learn. You learn collaboratively. So p-value is actual error. So you are expected to don't go beyond an error of 5%. Okay. Generally, you should go below 5%. But when it comes to normality alone, for some reason, R tends it to the opposite one. So please note that normally you want your actual error to be smaller. You want to make smaller error than what you're expected to make, so that you can have enough gravitas to reject the null hypothesis. The thing is that R tends this only for normality. R says that the p-value should be bigger than them for the data to be normal. In other words, it's true because For the data to be non-normal, the p-value has to be smaller. So for the data to be normal, the p-value should be bigger. So if you are praying that MPG, miles per gallon, should be normal, then you were expecting its p-value to be bigger than the alpha of 5%. Question is it bigger? Let's go and try that. Okay. So we are going to try to see whether we can check whether MPG is normally distributed. To do that, there are several tests of normality you can use. Look at them. We have the K-norm test, we have the Shapiro test, we have the Jacobera test, we have the Dagodet test. So many of these tests. You have the AD test, CVM test, P-Chi test, SF test, all of these, Anderson, Darling, Kremavon, Pearson, Chi-square, Shapiro, Francia, all of these are tests that one can actually do. Okay. What I want to do is I want to just take a smaller one, not a bigger one, a smaller one. And that test I want to choose is the Shapiro test. So let's try Shapiro test. Let's go to our R and type Shapiro dot test. Data into bracket, Shapiro dot test into bracket, data dollar MPG. Now, I was waiting for one of you to tell me why I didn't just write MPG, but I always have to bring the data in front because I am picking the MPG from the data frame called data. And so you got to direct it. Other than that, you have to attach and later detach so that you don't use the data dollar sign all the time. I've explained that in the note. So let's check, is MPG normal or is not normal? So you type this command, let's run it and see the result in the console. And look at the results down there in the console. This test, I told you, is known as Shapiro-Wilk normality test. So based on the results you are seeing here, would you say that MPG is normally distributed or is not normally distributed? The test statistic is the Wilk, okay, the W. The p-value is what you see here. So looking at the p-value, what would you conclude? If you are here and you're not fully getting something, you should write everything. That's my advice. And you know what the mind does is that the moment your mind tells you that I don't understand, then you switch up. After all, I don't understand, so I don't write. It's dangerous. The human mind doesn't like to think. That is why it thinks. That is here. The human mind does not like to think. That is why it thinks. That is why it should think. I can prove that to you. What is 2 plus 2?
Wow. Dog, 4.
4. I know you didn't think, but do you know you didn't think? I know you didn't think. And I can prove to you that you didn't think. Should I prove to you? Should I prove to you that you didn't think before giving me the answer? Or you get it now?
No, dog, please, I just have to understand, sir.
But I'm asking you, should I prove to you? You didn't say you're
Yes,
not saying
please.
yes.
Yes, please. Yes, please.
What is 258 times 724? You see, you are probably looking for a calculator.
Yes, sir.
You are thinking now.
Okay.
That is how I knew that the first one you didn't think.
Okay.
But you gave me an answer. And by you giving me the answer, you convince yourself that you are smart. But I know you are not. You only went into a portion of your brain or of your cerebral cortex, the part which is known as the cerebrum. and collected that information because information are stashed there. You learn and gave me the answer by memory. Your answer came from memory. It didn't come from imagination. Memory is things that have been stored that you bring them back. Imaginations are things that you put there. Not what is there, what you put there. That is why I know that the imaginators of the world are the movers and shakers of the world. That's why most of the imaginators of the world are billionaires. They imagine like going to live in Mars. Somebody might say that you are crazy, but that is imagination because God is imaginator. He created you and me in his image. The word image comes from the word imagination. So when you have a mirror and you look at yourself in the mirror, what do you see? You see your image. But you are created in God's image. So when God is having a mirror and God looks at himself, whom does God see? Catch them.
See myself.
No, he doesn't see himself.
No, God see myself because I was created in his own image.
Yeah, so God doesn't see himself. He sees you.
Yeah, he sees me.
So God sees me. So you are what?
I'm God.
That's it.
So this one should
This
give
is
me
not
math.
religious teaching. No, this is wisdom. This is not religion. Wisdom is the ability to see the obvious, even when the obvious is a secret. But you see, don't even think that you are God. Don't see yourself that you are God, but God has made you God. Himself. You are an extension of him. So if God is a creator, you too, you are what?
Creation.
You are what? That's it, news. I hope you guys are learning now. I'm normally one. If God is a creator, you see, I try to use this thing to expand your memory because the word PhD is love for wisdom. Are you aware? Doctor of philosophy. The word philosophy is love for wisdom. Are you aware? There's a Greek meaning. The etymology of that word is love for wisdom. But what is wisdom? Wisdom is accumulated knowledge and its application. Accumulated knowledge. And that word accumulated knowledge itself is what? Is knowledge. Knowledge in bulk. So you can be a knowledgeable fool. If you have knowledge and you don't apply the knowledge, you are not wise. And if you are not wise, the opposite of wisdom is foolishness. King Solomon said. So knowledge is always in continuum. That is why somebody says that I've done it already. You've not done it already. You can't finish. Knowledge is the only asset that creates, that multiplies all other assets. You cannot finish. That is why you can be a professor of medicine, but you are nothing when it comes to sport. You know nothing. You can die in the army. And yet you call yourself a professor. You are only a professor in a microcosm of life. You are nothing. Keep learning. Learning is life. Knowledge is the only asset that multiplies, that creates all other assets. That's why lack of it, Hosea forces, my people will perish. So have an understanding of your understanding. Question the orthodoxy. That is the essence of PhD. PhD means that you want to ask why. Why is your most important question? Not the what, not the how, the why. If you put is down, why did I write is? If you put the down, why did I write the? The why is deeper than the how, the what, and the when. So as a PhD student, you question all the time. And the more you question, the more you question, the more you question, the more your brain expands because the brain doesn't think unless you open it. That's why the word be open-minded is very important. Because once you open the mind, it's like a parachute. Hoo-ha, you can fly. Are you learning? Hope you are learning, oh guys. Hope I'm not talking to myself. So you got to learn, not just having book. Learning is not only academic. Academic knowledge is just 14% of the total knowledge. Learn expansively. Learn expansively. Learn. Learn by watching. Learn by learning. Learn by reading. Learn by, dancing. Learn by eating. Learn. Everything in life is learning. So there are so many knowledgeable people who are not wise because they think that knowledge is an end to itself. It's not a panacea. Okay, and so when I get into my mood of deep learning, sometimes I get anyway. So look at the p-value. Look at the Shapiro p-value. What does that tell you? It's 12.29%. What does that mean? Is NPG normally distributed or is not normally distributed?
Yeah, dog, I want to try.
Try.
From the background you gave, which means that the data should be bigger than 5% for the data to be normal. Referring to a p-value of 12.29% is bigger than 5%, and therefore we can conclude that data is normal.
Super. I agree with you. So MPG is normally distributed. Now, why should we have to check that? Well, maybe you are going to use it for regression later. You're going to use it for lasso regression. You're going to use it for, ordinary least squares regression. You're going to use it for other things. Okay, and maybe K-means algorithms and machine learning or artificial intelligence work and requires the data to be normal because certain things have to be normal for it to be acceptable. So you got to check for the normality of the data. We just proved that MPG is normally distributed. Then you can now go ahead and do your other analysis. You can later check on the other codes. Okay, other codes here. Okay. You can even check whether it's normal by looking at it graphically. Okay. You can use this command. So statistically, we've been able to prove already that it's normal. But I'm saying that graphically, you can also check whether it's normal. How do you do that? Watch this one. You can type this command, QQ data dollar MPG, QQ line data dollar MPG. Okay, so this is called normality check. When you check your notes, you see that. Check the normality. So this will check whether MPG alone, you can check the other variables, is normally distributed. And you just can see what I have on my right there. I'll tell you. Now you can add some color to this. So let's say after this, the line, let's say the line alone, we want to make it some color. So do COL. Okay. Oh, is that how it is? I don't even know this color. Let me see. Okay, so this one didn't work. Now the best way to do color is equal to, so COL equal to, then bring double apostrophe and type color red. I'm just trying to see. So now I have made the quantile normal probability plot or the QQ line. I made a line red. Of course, the plot too, you can change the color. Okay. You can change the color and you can command that I want the color for this one to be blue. So let's make this one blue and you can deepen it. Okay. The moment you type blue and it's blue, now the blue color shows because R is a sensible package. Some of you may know about R already. Some of you didn't know about R. I'm telling you, by the time you finish this course, you'll be grateful because you can use R for all your qualitative and quantitative work. Yeah. Well, Benedicta, your hand is up.
Yes, Doc. Please,
Yeah,
I
go ahead.
wanted to find out. So, if there's ever a case where you put in your command and then you don't add the hashtag what you want it to do, can the system still run the analysis?
Oh, yeah. The hashtag is not even for the system, it's for you.
Oh, okay.
Yeah. It will still run. You can see that the previous ones I didn't do, it's still running. And you can change different colors. When you check the notes, I have multiple colors you can use. I've given you, you have about over 100 colors that you can use. Sea blue. For example, you can use sea blue. Sea blue. It's not all of them that work though. It didn't work. It didn't work. I can use a turquoise blue. Some of the colors are strange. Yeah, someone. What did I say? Master, let me take my green out.
Hello, Prof.
Yeah.
Doc, sorry. Please, what I want to ask is, how do you interpret the plot?
Okay, I'm about to talk about that. So when the plot, when majority of the data are on the line, it means that the data is normally distributed. When majority of the data are on the line. So quantum normal probability plot is one way you show them to determine whether a data is normal. And when the data, majority of the data plot, majority of the data, you don't need all, just majority. Okay. Or most, not even majority, but most of the data are on the, then you know that the data is normally distributed. And I can tell you, when you look at this thing, most of them are closer to the line or are on the line. Okay. Most of them are closer to the line or are on the line. And that shows that it is normally distributed. But you see, the clue is that you should always use the test to support you. The test we just did. So use the test to guide you. Don't just do it all by yourself. Okay. Use the test to help you together. Okay, do you get a point?
Understood.
Get it? Okay. So that is it. Now let's look at another graph. Kingsley, your hand is still up.
Yes, Doc.
Yeah, go ahead.
The Shapiro test, is it a form of an hypothesis testing?
Yes. No, the Shapiro test itself is a test statistic. It's a test. You know, hypothesis testing requires 4 steps. 1, you formulate the
Yes.
null and the alternative
Yeah.
hypothesis. 2, you compare the test statistic with a critical value.
All right.
3, you find your p-value because alpha will have been given already. So you find your p-value, compare the p-value with the alpha. And then finally, you decide and you conclude.
Yeah.
So the null hypothesis here would be that the data is non-normal.
Oh, okay.
The alternative hypothesis here would be that the data is normal. So you reject, in this case, since the p-value is bigger, you reject the null hypothesis that said that the data is non-normal, and then conclude that the data is normal.
Right. Okay. Thank you.
Okay. Now, so that is the quantum normal probability plot. That is one thing that you can use to check for normality. Okay. There's another one, and again, it's not in the slides, that you can use to check for normality. Where is that? Okay. So let me see what I can catch one of them here for you, because it's not all the time. You can just type the word here. In fact, there are several of them, but I want to just take this. Okay. That's the one I just did some few minutes ago. We used Shapiro Shapiro test. Okay, so now I'm going to use this plot. It's a very powerful plot also to determine normality, and it's known as, and again, you can see this in the note somewhere. It's known as the kernel density plot. Kernel density plot is basically a smooth histogram, okay, that is able to do some few things here. I'm not going to do a lot of these things that you might see here, like giving the title of the plot, because anytime you have some of these red things, it means that the thing is not, there's a typo. So I'm going to use this command, but let me just delete this one for now. It's called plot, and I'm using plot into bracket density, data, and I'm calling it MPG. The line width will tell you the thickness of the line. So each number, you can do 2, you can do 3, you can do 1, you can do 4. It will tell you the thickness of the number of the plot I'm about to do. The color here was red. Then command. The RADGate gives you a jitter information. So let me just show you something. I'm doing it for MPG. You can change the jitter. I'll talk about the jitter when we get to kernel density plot, actually. But you can, it will show you how the kernel density plot at the bottom of it, there are some little lines that you use to beautify and shows the concentration of the data. So this is it. Just look at it here. So this is the plot that I've just done here. It is a whole lot of things because you have to select some bandwidth and other things that you use. But then I'm using everything to be the default. Now this line, it is thicker because I use 4. If I change the 4 to 1, you will see that the thickness reduces, as you can see here. Okay. If I go back to 4, the thickness more or less increases, as you can see here. Now, at the bottom down here, you will see the jitters, okay, the router. And you can see that the jitter is more in the center, that small vertical lines. It is plenty in the center because the peakness is there. That is where the peakness is the most. Okay? So there's a lot of concentration of the data around 20 or below 20 mpg, but more around 20 mpg. And if you can remember, the mean was also around that area. So the kernel density is a smooth curve that tells you the concentration where majority of the data is. In this case, mpg, majority of them, their mpg is around 20. And if you go back quickly here at the top, and then you go and check the descriptive data, the descriptives, the description of the data. Yeah. Okay. And then look at the mean. You will see that the mean for MPG was 20.09. So no wonder majority, the peak of this smooth histogram curve or the kernel density plot, it is peaked at 20. It looks like it's normally distributed if you check it. There's a little bit of, damp density and almost about to be bimodal. Okay, multimodal is when you have about more than 2 peaks. Here, the peak is the first one here. This first one is the peak. There's another thing that almost became like a peak, but it really didn't peak. Okay, so clearly we can say that it appears to be normally distributed. And I'm speaking, by the way, I'm speaking from my knowledge of the statistics, the test statistics from the Shapiro. That is what is convincing me, because the graphs are not enough. Okay, so always use the test to help you to determine the normality of the data. So that is a kernel density plot. It's also used to determine normality. That's all I'm trying to say. It's also used to determine normality. You can have another one, which we call lines. Okay, I'm just trying to do one here. Lines that will also help you to determine normality. This lines also gives you the same thing as the kernel density. This one, I changed the color to blue. So you can use plot density or lines density. They'll give you the same thing. So we've used two graphs, quantile normal probability plot. We've used those two graphs, one to detect normality and the other also to detect normality graphically. But the Shapiro test is the powerful one, and not just visualization. That test helps you to really have a feel of whether the data is normal. So we've been able to see clearly how to get that. Now let's get a feel of papers. That shows a bit about normality. Let's get some papers. There are papers actually you can look at to determine. In fact, in one of the 10 papers I will give you some papers and I'll tell you to critique those papers. Some of them are doing some crazy things, and your job is to critique the methodological ambience of the paper. This paper is by Margaritis and Silaki. It was actually published in 2010 in the Banking and Finance, Journal of Banking and Finance. It's a very, very good journal, top star journal. And this journal, did some descriptive analysis. I put it there, go and look at it. And it helps you to know some of the things that we have actually indicated. I've written some of the things they did here to give you a feel of what the paper was actually doing. Descriptive statistics is very good. You can use it to compare two things. You can use it to compare several things and find a feel or make a feel of what you are doing. Okay, now let's go to graphs. Graphs. There are so many graphs you will be doing. I've done a few of them for you. But I want you to know that the rest of this lecture for today are things I'm going to give it to you to be learning on your own. Everything in the lecture, which I've already given you, you should learn them on your own and practice some of the graphs that are used in R. There are so many graphs. You can do some of the graphs are here. Scatter plot, line plot, bar chart, histogram, smooth histogram. That's the one I just did. Box plot, dot plot, contour plot, image plot, 3D surface, 3D scatter, conditional plot, scatter plot matrix, parallel coordinates, star plot, stem and leaf plot, ternary plot, fourfold plot, mosaic plot. You can do most of these, and then the code for doing some of them and all of that idea. The kind of plot you do depends on the kind of work you do. When you are plotting, you need symbols, box symbols for some of the plots, like scatter plot, triangle symbols, mixed box symbols. The code, the numbers, and the pictures are all showing you here. If you want a star, you use 8. If you want a triangle, you use 2. If you want a plus, you use 3. If you want a times, you use 4. If you want a, dot with shaded, this with shaded. These are the various code numbers. And when you are writing, you use something like PCH, the position. Okay? The type of symbol that you want to use, the plot symbol, that symbol will be represented by. So once you write PCH, you write a number, and then you will get what you're looking for. You're going to try a few of them. There's another thing after you've drawn, what you should use. You can draw. Drawing is good, but maybe you want to label them, size them up, beautify them a bit. So there's one thing we call CEX, C-E-X. It tells you the size of the text or the symbol, the size of the text. So if CEX is big, it means that you want the text to be big. If CEX is small, you want the text to be small. You see examples. POS is another one. It tells you the position of the text relative to the symbol. So sometimes you can do this symbol, let's say star, and then you want to call this symbol G. Now G will be on top of it, or on the right of it, or on the left of it, or on the below of it. Where you want to indicate, you can see all of that out here. And then ADJ is a numeric of the length 1 or 2, the string adjustment for the legend. So this one is when you want to do legend. And all of the other ones are other cosmetic beautifications that you want to. I've just given you the kind of a blueprint here. The type of line is very important because sometimes you want to have zigzag line. Sometimes you want to have a normal line, double zigzag line, double normal line, dotted line, double dotted line, and all of that. The line width, I just demonstrated that some few minutes ago. So these are the type of lines, line types that I spoke about. Okay. So you want all of these, you might use some of them in your plot. And that's why I've given you. You want to label the axis, the kind of colors. There are 657 color names. Hoo-hoo! Hoo-hoo! By the way, you guys don't know R. I'm telling you, R is a very powerful software. It's what many people are using for artificial intelligence. And Python, I've also given you that. People are using it for AI, all AI related, business analytics related, business schools, economics, mathematics, department, English, science, anywhere people are using this thing. So please get used to it. These are some of the colors. And then the numbers that will generate those colors in case you want to use numbers. Okay. I'm looking at some of the colors and they look fantabruta, blue, black, and all of that. So as an example, let me see. Suppose I want to use this color, let's say 503. I want to go to the R, for example. And then when I wrote the 503, I'd rather use 503 instead of this and see. I don't know whether it work. I think it might, a different thing might work because there's something. There you go. It works. So by the way, this 503, that I picked it here. 503 here. You know, I picked it here. And yet, look at yellow, 653. So once you write, this time you don't put it in double apostrophe here. 653. So when I do 653 and run it, it will now be, oh, was that a color? 653. Is it? Okay. But it's cool, eh? You can, oh, yes, yeah. There are so many of these things that you can do. Yes, see your hand. Ben.
Yes, sir. Sometimes I'm not seeing your screen. Or...
You know what? What did you say? Guys, could you tell me what the person was saying? It was just...
He said he can't see your screen.
You can't... Do you all not see my screen?
Yeah, we can see your screen.
Oh,
we can see you. We can see
then you should have helped answer him for me. Anyway.
Oh, okay.
I see your screen.
Hey,
all right.
Okay, then I have to look at my settings. Thank you.
Okay, so that is how you do it. Okay, and you can do some couple of plottings and all of that. Now I'm going to do something very important here. Now here you can apply fixity, where you don't apply the dollar symbol, but I will say that leave it and let's keep applying the dollar symbol. So the first graph I'm going to show you, because we'll be using it a lot, is scatter plot. Scatter plot. So I want you to type this command. And wherever you see MPG, bring data dollar before you write the MPG. Data with the dollar symbol before you write the MPG. So in my case here, I'm just going to copy and paste it here. Okay. So, oh, and when you see weight as well, so also do data dollar before the weight. and then comma, do data dollar again before the MPG. The other things like the title of the plot. This is a scatter plot. So you want to know the relationship between the weight of the car and the miles per gallon of the car. That's what we're doing. The LWT is a line weight. Okay. Then the position of the thing, the color label is also here. You can have all of this. And then you can plot it. So let's plot this and see. Okay. So I think that we should remove. It says, so you get some errors. Sometimes you may get some errors. When you get errors, don't panic at all. Just read, could not find function lot. Oh, was there a function? Okay, maybe when I highlighted, I wrote lot.
Instead of plot, you highlighted lot.
All right. So that's it. Okay. So you can see that you have the data and you have a scatter plot. So you can see just by looking at the plot, you can see that there is some kind of relationship between the weight of the car and then the MPG. As the weight is increasing, the MPG is falling. Do you see a negative relationship there? I do.
Yes, Doc. Yes, Doc.
So it's one of the plots. It's one of the plots. Got it. Who has plotted it? Show by hands if you have plotted the lines. Let me see which people are following me. How many do I have? I have 3, 4, 5, 7. Some are serious though. The evidence will be clearer. Some are serious. Some came here to make an impact. Others came here to also make a non-impact. So 12. All right, good. Super. You can lower your hand now. So that is it. You can explain it. All of these things, we will explain them later, but this is just to give you a feel of one of the plots you can do. Okay. This is just graphical. Okay, it doesn't tell you the strength of the relationship. It tells you that there's an association. Yes.
Doc, please, mine this thing was 10, 20, and 30. But I think yours is 10, 25, and something. The plotting.
Oh, you
the
can
data,
change anything. Change them. Let it even be different. In fact, my blue color, instead of my blue, I can just use one of the colors that was
No, I'm
27.
talking of the graph itself, the plotting. 10, 15, 20, 25, and 30. Mine is just
Use
10,
anything.
20, and 30. Okay.
Okay. Use anything. Use anything, right? Okay.
Yes, please. Thank you, Doctor.
I'm changing some colors. I don't even know where they are coming from, but I just beat it. Anyway, so that is how is it. You later learn how to put a line through this. Joseph, your hand is up.
No, I think I'm done. I asked the
You
earlier
learn how
question.
to put a line through this to create a scatter plot and then come out with a regression. We'll look at regressions later. Okay. Another plot that you can do is histogram. Histogram. So I'm going to generate another plot, which is histogram. Histogram of the same data. We are generating histogram of the same MPG. But like I said, you could do any other one, not only MPG, any other. So how do you do that? Type hist into bracket data MPG, data dollar MPG. The color here, well, now instead of using a particular color, you can just use the numbers. 89. Here you have some breaks here, to indicate the level of the breaks, because you don't want the bins to attach to each other. So the X lab is a miles per gallon. So that's the label of the x-axis. So you want the x-axis to be labeled as miles per gallon. And then the color for that label says blue here, but I want it to be that. Then the main is always the title. Okay. The color of the main is also here. You can remove the title. Okay. I normally don't like the title, but you can remove the title because anytime you take your figure to a Word document or a LaTeX or a Lex document, you have to indicate the figure yourself. So which becomes a title. So there's no need to. Okay, so let's run this. And then you have another field of that. So the color I chose was a black color. So I've had a black color. Okay, that was 89. Let me use 99. Okay, and that will give me a green color. Anyway, so those are some of the things you can explore, you can experiment. Guys, explore some of these. Again, you can see that there's a lot of two bins at 20, around 20. So the peakiness is more around 20. So that is MPG for you. You have a feel. Okay, for that. Then you can also generate kernel density, which we have done already. Yes, Samuel.
Yes, Doctor. I wanted to know if there was a way of arranging this in ascending.
I can't hear you.
I wanted to know if there was a way of arranging this in ascending or descending order.
Arranging which one?
The plot, the histogram.
When you say arranging,
as in ordering the chart in ascending.
But normally histogram, you want the thing to be done. This is not a bar chart. This is histogram. Histogram, you want the thing to be as it is. It should be what it is. It's a concentration. If you want to arrange in ascending or descending order, you are moving. What about the numbers? The numbers here are telling you that there's a lot of concentration at 2. So you can't arrange in ascending order.
Understood.
Yeah, it's a distribution you are drawing, not the actual frequency, but then the distribution is what you're doing. All right, but bar chart, you can do that. Bar chart, you can arrange in ascending or descending. All right, the next graph that you can look at here, and I want to go bigger, okay? You can do multiple things. For example, the cylinders. Yeah, I don't want to draw that, but it's in your slides. The cylinders. You can draw different categorical variables. This is very important. What you've seen here, top journals like this, where you can generate kernel density plots for different categories and look at how the distribution are different. Okay? So maybe you want to look at foreign banks, domestic banks, and then state banks. And you want to compare the distribution. Okay? And you are able to know that there's a lot of disparity among the state banks. And the reason for that is because there's a lot of government control among them. So you can say, using kernel density plot, you can draw different distribution of things. I'll give you an example here. I've also given you an example of bar plot. I'm not going to show the rest. You can now go and use the code to show the rest. And familiarize, just go through each one and plot each one. So this was the number of gears. There were 3 gears, 4 gears, and 5 gears. I used bar plot to show the distribution. You see now you can show the ascending and descending order because this is a categorical variable. And you can show clearly the way they are looking like, which ones are the highest, which ones are the lowest. You can also do the distributional plot for bar chart in a horizontal fashion. So the same thing, but this time in a horizontal fashion. Okay, you can show that. You can show stacked bar plot. So here, I show the number of gears across whether the car is automatic, across VS, vertical speed. So if the vertical speed, this one is interesting because it's here actually. So here I create a table, and then after creating the table, I compare the vertical speed across gears, and I show the stack bar plot for that. It's very, very, beautiful. So sometimes you want to, for example, let me show you. So you can see that we know that the highest the highest gear was gear 3. Okay. Now, among the gear 3, you have the vertical speed. And which vertical speed is higher? You can see that this vertical speed that was coded as 0 is higher within that gear 3. Okay. But the vertical speed among gear 4, the one that is coded as 1 is rather higher in gear 4 than it is in gear 3. So you're able to do some analytics, based on the way that it's just like the contingency table that I did. That is a similar thing that you are seeing here. But this is done for stack bar plot is for categorical variables. It's like you are comparing two categories. The number of occurrences for those categories. You can also have grouped bar plot. So it's the same thing as a stack bar plot, but this time you are separating them and grouping them the same way. That's another one for that. You can have lines. Lines are mainly for over time. So if you have something across time, like January, February, March, temperature over time, you can use time for that. And you can plot different things over time. So this is MPG, that I decided to plot. There is no time because this data was actually a cross-sectional data. But then I just plotted this MPG, and showed how MPG is sort of being indexed, like how is the MPG, over across the individual 32 cars. How is the MPG looking like? And you can also use multiple line plots to distinguish one line plot from the other, which is what I did here. You can compare plot, you can use different plot colors. You can use different attachments and detachments. So here I'm adding more things to the existing one. Excel can do this too. Okay. To be honest, sometimes I kind of love, when it comes to line plot, I love Excel than this. That's my own. You can also put all the plots together. In fact, I did this here. So you can do a scatter plot and then use another one and put all of them in one place. Multiple line graph, all put together in one line place. I've done it there for you to have a look at. Then there's a box plot. I'm just going through quickly all of this for you to go and work on your own. Box and whisker plot is very good when you want to detect outliers. Okay. It can help you to detect outliers in the data. And the explanation is that you have the 75th percentile, that is the upper quartile. Then the 25th percentile, that's the lower quartile. 50% of the data is within this section here. The second quartile is the median. You have the whiskers, and you have the outlines also showing. And there's even a better plot, which is called a volume plot. Take note. I don't think I showed you. The volume plot is even an advanced version of the box plot. It is not only showing you the central tendency, but it's also showing you the distribution. The box plot is not showing you the distribution, but the box plot is helping you to detect outliers. But the volume plot even shows you the distribution. These are box plots for different groups that you can compare. And just by looking at the plot, you'll be able to have a feel. Here, you can see that the four cylinders are showing the greatest of mean than all the other cylinders. Ladies and gentlemen, I have given you a lot of these things that I want you to check on, go through them yourself, because I want to end this particular visualization, because next time we meet, we are going to go into a hypothesis testing before we come into the real deal. So look at these yourself. I know I've rushed it through, but look at them yourself. I've given you a couple of references for papers that have used these things so that you can familiarize yourself with. There is a 2D box plot you can look at. Okay? There is a bar plot. It's a beautiful plot. It's a kind of a 3D, 2D mixed together plot. Interpretation of this plot, I've given it to you here. You can look at it. There's a scatter plot matrix. You have that here. I did it for MPG and for the rest. The code is there. There is a 3-cylinder options that I also showed you here. There's a 3D that I did for MPG, weight and displacement. But it's beautiful. When you look at it in the actual one, you see that when you click on it, you drag it, the thing will be dancing beautifully. And this is like the scatter plots are inside it, inside the cube, like a cuboid carrying water scatter plot. You have it there. Scatter plot matrix is when you throw in a line, but this time, because it's a 3D, it's not a line, it's a surface. It's a surface. If it's a 2D, it's just a line. If it is a 3D, it's a surface, and it's really, really nice. How does all of this? You can even have a spinning 3D. I did that. So this one, you are spinning it, and as you are spinning, it's like the dots are pouring and coming out and pouring and coming out. It's another beautiful thing that I did. You can check the codes. You can combine multiple plots like this. I've shown you already, where you combine all of them into one page, which is good. And then you can 3D some plots and also show the locations of the 3Ds. It's just great. It's just great. I did that, and you can check that as well. Okay. Then you can do surface plot. We use this a lot when you want to look at densities. Okay. You can use a lot of surface plot. You use this a lot in geo locations, especially those in the geo mappings and geolocation centers. You can do that. So my interest to conclude is your assignment, your term paper. I give you the term paper in the early days so that you start preparing. So this is a term paper. You are going to take 1 or 2 papers. I'll give you the papers, don't worry. That use any 2 of the techniques we are going to learn or we have learned. Descriptive statistics, hypothesis testing, confidence interval, ANOVA, regression, limited dependent variable, factor analysis, principal component analysis, structure equations modeling, panel data model, all of these things. You are going to take the paper, the papers that I'll give you, 2 techniques. Yours is to critique only the technique of the paper. The mathematical nature of it is not too mathematical. Some of the papers are from HR. Some of the papers are from public admin, health services. Some of the papers are from marketing. Some of the papers are from accounting, from finance, from operations, from MIS. So the papers are from a diversity so that nobody will say that this paper is not in my area. And there's a paper that cuts across all of them. Yours is to provide a good critique of the paper, not the conceptual framework. Consider if the approach taken meets the aims, how the data was used, what problems were encountered, how these were handled. Indicate any problem with analysis, what conclusions it legitimately enables one to draw, how this may differ from the conclusion. I have this assignment proper in a Word document with further information that I'll give you. This will have 40% of your entire work. You will submit this paper on the day of your exam. Not now, on the day of it. So you see that there will be an exam timetable and they will have exam timetable for this module. That day, the time the paper starts is the time you are finally supposed to submit. But you can submit this paper from today, anytime you like. You submit a hard copy and a soft copy. I'll show you how. Credit will not be given for just giving me a synopsis or per se of the paper, or repeating any limitations the paper has already done. Don't summarize the paper. Don't summarize the paper. That's why I'll give you the papers, corrected papers, so that you don't go and pick any paper. Okay. Now, critique the quantitative ambience of the work. Don't go and critique conceptual film because the paper is on CSR and you know a lot about CSR. You're going to critique. No, it's a mathematical and the quantitative and the statistical work the paper has done. That's what you are critiquing. And I've deliberately selected papers that have a lot of criticisms with them. Do that and you will be fine. Ladies and gentlemen, that brings us to the end of the entire caboodle. At this stage, you know you may have some questions. Please, I'm all ears.